So my name is Narayan Venkat. I am part of the data center systems business, so we're going to switch gears. We've been talking about bits, bytes, process technologies, semiconductor technologies to hard disk devices, et cetera. We're going to switch gears and talk systems. So obligatory, disclaimers. So I'm not going to go into details. But before I get into the details of the data center systems business, let me give you a little bit of context, which is the company, Western Digital, decided that we're going to start building systems. So about 3.5, 4 years ago, we launched our data center systems business, and over the course of time, we've been expanding our portfolio. And so we've grown quite a bit from a data center system standpoint. Obviously, being a public company, and we don't report the data center systems numbers, but just by way of giving you, by way of some numbers here, I'll give you a perspective of how we've grown. So 17x revenue growth. We got about 3,000 plus customers just for our data center systems business. About 8,500 systems deployed, 3+ exabytes shipped in 2018. So we're not a small player in the systems business, adding about 150 new customers every quarter. And the broader data center systems business has about 450 plus engineers working across a wide range of products. Okay. We're seeing success, as you would expect, across a variety of different growth markets. So just a few of these. And let me get into the details of the portfolio. So the portfolio spans today across a variety of different markets and a variety of different products. So platforms are the underpinning. So in addition to delivering SSDs and HDDs, we're now started to get into the market of putting together full platforms, i.e. JBODs, JBOF, storage servers. So those are the underpinnings. We've also introduced software composable infrastructure. I know Scott Hamilton is going to get into more details of the OpenFlex architecture. That's our NVMe over Fabric solution as well going forward. In the last storage field day, that was probably a while ago, we talked quite a bit in detail about our active scale object storage systems. And today, we'll spend a little bit of time talking about IntelliFlash. I'm going to cover IntelliFlash, and then I'm going to request Shailendra to come in and talk about the innovations that we've done within the file systems, et cetera, right? So just to sort of reiterate what has been said, so we got a pretty strong portfolio. And going back to the silicon to system story, if I just took a view of the NVMe space, what are we doing in NVMe? Needless to say, it's 64 and 96 layer NAND, SSDs. We're going to talk about OpenFlex, which is composable NVMe over Fabric systems, and then all-flash arrays. So I'm going to jump into the all-flash arrays, and then we'll cover the OpenFlex portfolio. So our portfolio of all-flash arrays, we call IntelliFlash, ranges from SAS-based all-flash arrays to more recently NVMe-based all-flash arrays. Single operating environment that runs across all of these products. So we have a number of customers who start off one way or the other, and then expand across. So high level, we've introduced this product probably about a year, tremendous traction in the market space. 5200 and 5800, 50% lower latency than our SAS-based products. We're seeing very good traction and consolidation, i.e., from a customer perspective, we're starting to deploy more and more NVMe AFAs in the market for a wide range of apps.
And the front-end protocol for that is?
Yes. So the front-end protocol for that is block, Fiber Channel iSCSI, NFS, and SMB3. So it's a true multi-protocol system underpinned by one common data management layer. And then we've done a lot of the optimizations. And I'll have Shailendra talk about the specific file system optimizations we've done as it pertains to NVMe.
Multiple protocols within the same array?
Within the same array, deployed concurrently.
So are we talking about volume separated? So you create a volume, it's block. You create another volume, it's SMB3.
Great question. So you create a volume that's a virtual volume. You can export that over NFS. You can export that over SMB3. You can export that as a...
But not multiple within the same volume.
No, that doesn't work, right? Generally doesn't work.
backend file system?
Yes, it has a file system. You can do snapshots, clones, thin provisioning, dedupe, inline compression, inline dedupe, replication. Anything else I'm missing? No. Okay. But yes, so a wide range of our customers typically deployed this for databases, as you would expect, for NVMe. Lots of SQL Server databases, lots of virtualized deployments, lots of large-scale, low-latency analytic applications, and deployed over block and file concurrently. OK, so with the N series, which is the 52 and 5800, they fundamentally differ by CPU memory footprint and the types of SSDs that we're using. Let me look here. So direct access to flash memory. So from a latency standpoint, substantially better than what you would expect from a SAS-based system. So we can do 200 microsecond latency. The system's actually designed to take advantage of different media types. So one of the core components of our software stack is to be able to handle different grades of media. This system is optimized for NVMe. But the software architecture is such that we can take advantage of any higher performance tier of, I know we were talking about persistent memory and the likes. So our software is designed to take advantage of all of that as well. OK, so that's IntelliFlash software. So we've been at this for, I'd say, the better part of almost 9 years now. The software has evolved pretty extensively. We've got all of this. So one of the core capabilities of the software is that we're able to separate metadata from your application data. And that has allowed us to scale quite extensively in terms of performance, doing inline compression and inline deduplication.
Narayan, you said 200 microsecond latency. Is that like fiber channel read latency kinds of things to the system?
That depends on, obviously, what protocol you're going to deploy, right? So for example, you're going to see slight differences in latency between SMB3 versus fiber channel. So end-to-end latency purely depends on what type of a
so
interconnect.
200 microseconds would be like a fiber channel type of latency to the system.
Yeah, yeah.
OK.
Data protection, as I said, we can do snapshots, clones, inline compression, dedupe, compaction, asynchronous replication, as you would expect of any enterprise.
And the data
flash
compression
storage.
is software?
Data compression is software, fully inline, right? Deduplication is also software, fully inline.
And does the device have a cache as well as it go directly to the NVMe? So
yeah.
It must go someplace before it gets to the NVMe
Yes.
SSD.
So, and I'll let Shailendra go into more details of it, but the short answer is we scale, performance of the system scales with CPU and memory, right? So it's software driven. We use NVDIMM in the architecture, so we take quite a bit of advantage of NVDIMM. And so we're able to compress inline and dedupe inline. And then the rest of the stuff. So pretty much what you would expect of an enterprise storage system. We see a number of customers deploying that. We also have what we call cloud-based management. We grab data information and data coming from the system, hosted in an AWS cloud.
I didn't see NVDIMMs on your product roadmap. Was there something I missed?
We've been using NVDIMMs, oh God knows, for better part of 5-6 years, or at least on this platform. I don't believe that Western Digital has an NVDIMM portfolio.
Yeah, you're not selling it.
No, we're not selling
Okay.
it yet. Again, keep in mind that this is, we talk quite a bit from a, semiconductor and HDDs and SSDs. Now we're talking systems, and systems require a combination of other things that we source from outside.